even up the end of this box tubing. And I am using a silver pencil instead of soapstone for a nice fine line, and this wide base square. It's called a square. You can learn more about them on weldmonger.com. But you see how it's easy to transfer the mark even over a big radius like that. The wide base lines up really nicely with the previous line. That's very useful on any size square tubing, and you can even make pretty good marks on round tubing with that base. And it stands up by itself too, which is really handy when you're working by yourself, which I am almost all the time. Alright, so I'll get a couple of more marks here. I'm gonna mark off 2 pieces 2 inches long. The reason for 2 pieces is I need 2 welds to make this video with. I got to use one for the the overall shot, and then one for the arc shots, and that's pretty typical. That's the way I do it anyway. I just never can do it all in one, very rarely, which is a problem when somebody brings me a one-off, because then I got to do a one take and get it right, arc shots and macro shots. Alright, so sped up here, we'll get this stuff cut, and then I will clean it up, clean all the dross off with a grinder, and all the mill scale off around the base plate as well as the square tubing, and it's positioned up in this weld test stand from Triangle Engineering. We'll set this over to stick. This is the Lincoln Power MIG 210 MP, the first chance I've had to use 7018 rods with it. I've heard it does a really good job with 7018, and we're going to find out in this video. So I'll take it through the settings. On stick welding, you've got a couple of extra controls on this machine. One of them is called Hot Start, and it will let you bump up the amperage for about a second or so to keep you from sticking the arc, and the other is Arc Force. And for 7018s, generally you want the arc force fairly low for a nice smooth arc, but there are applications when you may want it higher, so you can just bury the arc. If you set the arc force up high, it will bump the amperage up as it senses the arc get tighter. And that sometimes is to remember all the variables, as well as a good way for instructors to remember the variables. So current here, I settled on 125 amps. I would actually like a little more for the overhead and the horizontal, the bottom and the top, but 125 is pretty close to just do the whole thing. Be hot at times for the uphill if there was any gap at all, so I even had to bump it down to about 115 a time or two. I'm twisting my wrists as I go around the corner to try to maintain a good rod angle. And so next we'll talk about rod angle. For the vertical up, I'm going to try to use straight in 90 degrees or a slight push. I'll aim for 90 degrees and probably wind up with a slight push. For the overhead and the horizontal, for the bottom and the top, I would want to use just a slight drag angle, maybe 10 degrees. But it's very forgiving, fortunately, because in the field, doing a joint like this, you get in all kinds of angles, and you just do what you got to do. Now, I'm not using any terrific amount of electrode manipulation. I just use a very slight, usually a very slight upside down V type motion, or almost none at all. Main thing is just to keep a tight arc. There we are, coming around the top radius, and again, just kind of turn your hands and try to maintain a decent angle. Looks like I'm doing a slight push here, but once that puddle is going, it's even more forgiving. Once the puddle's good and hot and going, when you're first starting out, lighting up with a fairly cold puddle, rod angle is a little bit more important. Now when you brace yourself and you have to weld with one hand, sometimes it's good just to kind of lock your elbow into your side. You're going to have to weld with one hand a lot. Preferably I use two. I prop with two and kind of use both hands, pinky to thumb type technique, but here I'm just propping with one hand and welding with the other. But I do have my elbow kind of locked into my ribs. And again, shooting for about a 90-degree angle with a really tight arc. And so the L for length of arc, keep a tight one. I always tell people, best advice for stick welding is set the machine hot enough, just hot enough where when you hold a really tight arc it won't stick, then hold a really tight arc, and that winds up usually, like say for a 7018, around 125 amps. So this is just gravy coming across the top here. with that first pass. You could use a dead straight arc, very slight drag, or quite a bit of angle. And in some cases, if you set the machine up a little hotter and you have to get a push angle, you could even do that if something is in your way. So that's one pass. We'll speed things up along here a little bit, going the rest of the way. So far we've talked about current, length of arc, angle, and manipulation. Travel speed is pretty much just dictated. You got to go slow enough not to leave undercut, and you got to go fast enough not to build up too much metal. That just kind of becomes second nature after a while. The 7018 just kind of burns how it wants to burn. I'm trying to overlap just about halfway the previous bead, and again turning my hand to maintain the right angle as I get to that radius, making around the bend. You see I'm using both hands here and just feeding both hands in. That's my preferred method. See how tight the arc is? You don't want to just jam it in there. If you jam it in there, it'll almost snuff out and kind of bulge the weld upward because there won't be enough arc length. But you got to jam it in pretty tight before it's too tight. Okay, last time around here, starting on the bottom again. The reason I'm doing multi-pass weld on this thing, structural welds like this will have a minimum fillet weld size that you have to get. You got to put a certain amount of weld on there. It's usually inspected by a welding inspector with a fillet weld gauge, and so for the thickness here, this is somewhere pretty close to what you might expect. Just depends on the drawing requirements. I'm keeping a real close eye on the right hand side of the puddle, trying not to leave any undercut. And that's another reason for cleaning all the mill scale off. It's a lot easier not to leave undercut when you don't have mill scale. Also, it's just good practice, and most of the time it would be in the policy, in the welding procedure, to clean mill scale. Speeding everything up here so you can just kind of see hand positioning, feeding the rod in and turning the wrist as I make the turn there. Alright, this is the very last bead, so I'm keeping an eye on the very top to not get undercut and trying to center up on that previous bead halfway over. And that's a wrap. Take a quick look at the bottom here.